Okay, class. This is also part of the normal distribution PowerPoint that I created. But these questions are a little bit more thought provoking than the original ones that we saw. Okay, so here, previously we've just here's some numbers, solve for the probability, solve for this, solve for that. But in these next two questions, you've got to kind of read it, interpret it, and find out some answer based on some property of the normal distribution. Okay. So, as a background for this next question, we're just talking about the ACT score and the SAT score, which are the tests that students take to get into college. Okay, the ACT score is scored from 1 to 36, and in recent years, as of the publication of this textbook, they were normally distributed with an average of 20.9 and a standard deviation of 4.8. The SAT, on the other hand, ranged from 400 to 1600. Now, my textbook is old because the SAT actually now runs to 2400. But at the time, and this was 2005, the SAT was normal 1026 and 209. Let's just keep those numbers in the back of our head and see what kind of questions that we ask. Tanya scored 1318 on the SAT, and Jermaine scored 27 on the ACT. And the question says, assuming both of the tests measure the same thing, who has the higher score? Okay. Now, in this case, we got to realize that it's relative because you got to compare Tanya's score to everyone else who took the SAT and find out what percentile she was in. And you have to find Jermaine's score and find out what percentile he would have been in. And then you can compare the percentiles and see which one is larger, and that person is the one who did better. Okay. So here's Tanya. Okay. If you imagine having her standardized value. So, the average was 1026 for Tanya, and she was somewhere over here at 1318. Okay. So what I want to know is find out how many people did worse than Tanya. And I can do that by finding her z-score, which is just 1318 minus 1026 divided by, the standard deviation of this was 209. This is equal to something. So 1318 minus 1026 divided by 209 gives me 1.40. Okay. Now, Jermaine, his z-score, we're looking at next. But his was centered at 20.9, and he scored a 27. So again, I'm looking at what's less than it. So 27 minus 20.9 divided by, his standard deviation was 4.8. And I now can calculate this, 27 minus 20.9 divided by 4.8 gives us a 1.27. Okay. So if you think about the normal distribution, 1.40 is further to the right of 1.27, which means 1.40 has more people has more area less than it than 1.27 did. Which means if we took this out to find out what the percentile was, we would see that Tanya's percentile is actually greater than Jermaine's percentile. Okay. So since we know that Tanya's percentile is greater than Jermaine's percentile, we know that Tanya actually did better than Jermaine on the test. Okay. So there's a way where you compared the z-scores to find out which one was more like the rest, and that other person did better. So basically, the outlier is what we're looking for. The further out you were, the better off you did. Okay. Next, same kind of question, except Jacob scored 16, and Emily scored 670. So I'm just going to put Jacob's stuff here. 16 minus 20 over 4.8 So that's 4 divided by 4.8, which would give you 0.83. And now Emily is 670 minus 1026 divided by 209. And her number is 670 minus 1026 divided by 209. Negative 1.70. So clearly, Jacob did better than Emily because his number is greater than her number. So if I were to draw a distribution, you see that negative 1.70 is out here, and negative 0.83 is here. So this area is larger, which means that Jacob did better than Emily. Okay? That's question number 4. Okay. Next question. Here's one where the heights of women are given to you. And so the average height is 64 and the standard deviation is 2.7. And men also have their height shown, average of 69.3, mean of 2.8. And it says what percent of young women are shorter than men, the mean height of young men. Okay? So you got to think about what it's really telling you. If I drew my picture, I'm centered at 64. And it says what percent are shorter than the mean height of young men. Well, what's the mean height? The mean height is 69.3. So that's here on the women's distribution. So I want this area here. So I need to find out the probability that X is less than 69.3. I can convert this to a z-score by saying 69.3 minus 64 over 2.7, and this will give me a z less than, looks like it's, well, I don't know, 69.3 minus 64 divided by 2.7, 1.96. Oh, wow. We know something about 1.96 because we know that it cuts off the middle 95%, right? So there's only 2.5% that's above it. So this would be 0.975. Now we could have found that by looking at our table as well. You would see that 97.5% of the women should be shorter than the average male. Okay. Question number. Scores in the ACT are 20.9 and 4.8. And in all, we had a whole bunch of people who took it. And this many had scores of 27 or lower. Okay. So the question is, if the distribution was normal, what percent will be 27 or lower? All right, well, that's an easy one to actually solve. Let's do that first. Okay, so if we did 27 minus 20.9, I'm going to put it up here now, divided by 4.8, we'd get some number. So you have 27 minus 20.9 divided by 4.8. I got 1.27. And then you'd have to look at your table to find out what amount would be 1.27 or lower. So I don't see oh, there's my table. So 1.27 breaks off the middle of the lowest 0.898. So 0.898, probability that Z is less than 1.27 is 0.898. So what percent would be less than 27? 89.8% of them. Next question. What percent were actually lower than it? Here you just have to divide. So you have 10, 52490 divided by 1171460. Sounds like a calculator job to me. 1052490 divided by 1171460. 0.898. So theoretically, I should have 89.8% of my data less than 27. And realistically, I had 89.8% of my data less than 27. So does the normal distribution fit the data? Oh, yeah. It fits it wonderfully. Okay? That's question number 6. I actually did this already. I just have it 3 different. Number 3, blank, 4. So here are the references for the class, for the questions that I pulled off for this particular talk. Thanks a lot. Talk to you guys in class on Thursday. See ya.